Okay, so the next example that we have is determining where the intervals where the function f of x equals to x plus 9 divided by x is either increasing or decreasing. So here we have a function. I'm going to write the function into a slightly different form. So x plus 9 times x to the power of negative 1. And I'm only doing this because to determine the intervals of increase and decrease, you first need to determine the derivative. And this makes it easier to find the derivative. The other thing I want to note is, notice here that we have an x in the denominator. Division by 0 is not allowed, so this function has a domain. Domain of the function is all real numbers. X cannot be 0. That 0 is going to be important later on because we're going to exclude that from any of our intervals. Okay, so let's take the derivative. If we do that, we get derivative of x. We could just do term by term differentiation followed by power rule. So we get 1. Derivative of x is 1. Derivative of 9x to the power of negative 1 is negative 9x to the power of negative 2. I'm going to write this into a form that's a little bit nicer. And then the next thing I'm going to do is combine the two terms here into a single fraction. So if we do that, we get x squared minus 9 divided by x squared. Then the last thing I'll do is factorize the numerator. So x plus 3, x minus 3. Okay, and then that's it. Now, this is very important to do. So number 1, I took the derivative. But number 2, I rewrote the derivative with positive exponents and then combined it into a single fraction factorized. Okay, this process of simplifying the derivative and factorizing is very important. The reason it's important is because we've defined increasing and decreasing. We've defined functions to be increasing or decreasing based off of whether the derivative is positive or negative. And you can only determine whether the derivative is positive or negative if it's in nice, easy, simple factorized form. Once it's in simplified factorized form, we can then make a sign chart. So I'll put that up here. So here's our sign chart. And on our sign chart, what we're going to do is we're going to include where the function, where the derivative is undefined, and also where the derivative is 0. So the derivative is undefined when x is 0. And the derivative is equal to 0 when x is negative 3 or positive 3. I'll note that x equals 0 is where the derivative and function are undefined with a dotted line, and I'll use solid lines to indicate that at x equals negative 3 and positive 3, we just have the derivative being equal to 0. Okay, and this will be important later. So this is x equals 0 is an undefined y value. Okay, so let's mark in the derivative, and let's determine whether the derivative is positive or negative in these intervals. So first we have to check to the left of negative 3. We can try a negative value like negative 100. Negative 100 makes this negative, makes this negative. This will be positive. So overall, we have positive. Between negative 3 and 0, we can try maybe negative 2. Negative 2 makes this positive, negative, positive. So overall, we're negative. And then you can confirm that it's a negative and then a positive. The reason there's no sign change around 0 is because we have a square factor here in the denominator. But you can just double check that these hold. Okay, so these are the signs of the derivative. Next, what we can do is determine, the intervals where the function is increasing and where it's decreasing. So in this interval, so underneath I'll put f of x. In the interval to the left of negative 3, the function is increasing. Between negative 3 and 0, the function is decreasing. Between 0 and 3, the function is decreasing. But after 3, the function seems to be increasing. Okay, and this kind of gives me a rough overview of where the function is increasing and decreasing. You do have to be careful at the endpoints though. So negative 3 will include that endpoint. 0, we're going to exclude that endpoint because it's a asymptote on the original function. And then 3 will include as well. in our intervals. Okay, so the function is increasing on which intervals? Well, we just look to see where the derivative is either negative or, we look to see where the derivative is positive or 0. So we can see that the derivative is positive to the left of negative 3, and we also include negative 3, so we can say x less than or equal to negative 3. And we can also include the interval to the right of 3. Okay, so x value is bigger than or equal to 3. And so that's one of our answers. That's where the function is increasing. And we can say the function is decreasing on, and here what we can do is we see, well, between negative 3 and 0, the derivative is negative. Function is decreasing, and we're going to include negative 3, but we have to exclude 0 because 0 makes the original function undefined. So we're going to say between negative 3 and 0, excluding 0, and between 0 and 3, excluding 0. Okay, and that's it. That's our answer. Now, the concept here is pretty straightforward. It just kind of comes down to finding the derivative, seeing where it's positive or negative, maybe where it's 0 and undefined, and then making a conclusion based off of that. But the later examples will show you that the calculus aspect of this is actually not so bad. What's more difficult sometimes are the functions that they give you, and I'll show you that in the next two examples.